All right, Bismillah. So I'm making these videos more to teach myself as well. I'm just gonna say that right before I start. I'm not a teacher. I'm just a student. But perhaps you may benefit from this as well. So we're gonna be talking about pHs and pOHs and how to solve them. So when it comes to solving solving pH or pOH, there's two things you need to think about. Number one, is it a strong acid or base? And two, is it weak? So when it comes to these two, there's different methods to solving them. And we'll talk about it. So here, HCl, what is a pH of a 0.0235 molars? So this is the concentration of HCl. We know HCl is a strong acid. Therefore, it's pretty straightforward. You use the equation negative log of the concentration. You enter the concentration and you get the pH. And it's pretty straightforward because it is a strong acid. Now, what is a pOH? We know that pH plus pOH is equal to 14. This is a law, right? That's about 4. So if you have one of the other, you can always find the other. So in this case, we calculated the pH in this one. The concentration remains the same. So we just do 14, subtract our previous answer, and we get the pOH. And then we see that it's the correct answer. Now, when it comes to weak acid and bases, it gets a little tricky, but the general form is the same. And I'll show you what I mean. Now, how would you know? Let's say you haven't memorized the strong acids or bases. How would you know if it's something is strong or weak? Well, they would give you this constant. They would give you the acidity constant or the base constant. So we have Ka, which means we have the acidity constant. So 0.025 molarity of solution of acetic acid has a blah 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 of 1.8 times 10 to the power negative 5. Set up ice tables, which is what we're going to do, and calculate the concentration of the H ion, the pH, and the percent ionization. We're not going to be talking about percent ionization. We're just going to be talking about the pH. All right, so let's do it. So let's start off with writing the equation. We have CH3COOH, right? And then it's going to break apart to CH3COO minus plus the hydrogen ion, and that's the equation. Now we're going to set up ice tables. So we have the initial change of concentration and equilibrium, right? So what do we start with? We start with 0.025 molarity. 0.25, my bad. 0.25 molarity. That's the concentration. We started with 0 and 0 here. Now there's a change. We're losing a little bit. We're gaining a little bit. Plus x and plus x. If you don't know the coefficients to put, just look at the coefficients here, and that's the amount of x you're going to put. Now we solve it. So refer back to equilibrium and the previous unit. So we're going to do x squared because these two get multiplied. Minus. Now, pay attention. This is a very small number. So we could just pretend that the change of x is very small. So we could just put 0.25. And this is how you're going to be solving like 99% of these problems. You're not going to worry about the x for the denominator. Equals to the acidity constant, 1.8 times 10 to the power of negative 5 over 1. We're going to cross multiply, so x squared is equal to 0.25 and 1.8 times 10 to the power of negative 5, right? And if we want to find x, we just take the square root of that. Oops, that's a bad square root. And you're going to get your concentration for this, for the hydrogen ion, which is what the first part is asking for you to do. Then we're going to find the pH. All right. So plug this into your calculator. Uh, I'm gonna find x squared first. Actually, you know what? I'm just gonna go straight into it. Okay. 0.25, 1.8 times 10 to the power of -5. You should get your x if you just do the square root. All right, so x, which is also the concentration of the hydrogen ion. That's a really bad equal sign. Okay, that's a little better. Is equal to, we'll keep it at 2 sig figs, 2.1 times 10 to the power of -3. Now we need to find the pH, right? So since we have the concentration of the hydrogen ion, we could just find the pH right now. So pH is equal to the negative log of the concentration of the hydrogen ion. Oops, okay, which is 2.1 times 10 to the power of -3 is equal to, so we're gonna do negative log, and we're gonna do 2.1 times 10 to the power of -3. And we're gonna get our pH, 2.6. Yeah, we'll keep it at 2.6 time. No, that's your pH. So you find your pH. Now let's go one step further. Let's calculate the pOH, right? It's just gonna be 14 minus 2.7. Ugh, damn, that's really ugly. 2.7. That's equal to, oops, 2.7. You're gonna get 11.13. They're not asking for it, but just so you know. Anyways, let's see if our answer is correct. 2.67, yeah. I rounded it to 2 sig figs, which is fine. So 2.67, 2.7. Did we get the concentration correct? Let's see. Where's our concentration? We got 2.1 times 10 to the power -3. 2.12. Yeah. So yeah, this is how you solve a let's put it here. Weak acid slash base problems. Pretty good. All right, let's go to the next one. Same thing. A 0.10 molarity solution of HA has a acidity constant of 3.2 times 10 to the power -4. Since they gave us this acidity constant, we're gonna assume it is a weak acid. So let's. I don't know what HA is. I never heard that in my life. I think this is a made-up acid, but nonetheless, we could do this HA. So it's gonna break up into a hydrogen plus ion plus an A minus ion, which I've never seen in my life. We're gonna do ice tables as usual. So initial change, equilibrium. They gave us the initial, which is 0.1. Once again, we're gonna assume 0 here and 0 here. That's still a different color. I don't like this. I don't like this. 0.10. And we're gonna assume this is 0, and we're gonna assume this is 0. There's gonna be a change here. They're gonna gain here, right? Please refer back to ice tables if you're having trouble with them. You're gonna struggle with this question. Again, I'm gonna go straight into it. Since again, this is a very small number, very small, we're gonna assume the change is almost negligible. So it's gonna be x squared. And again, you're gonna be solving it like this with like 99% of the problems. 0.10. Again, we assume this is negligible. And that's equal to um the constant 3.2 times 10 to the power of -4 over 1. I'm gonna go straight into it and solve for x. So x is equal to the square root of 0.10. And then 3.2 times 10 to the power of -4. I apologize for my handwriting. X is equal to, let's get our calculator out. Oops, nope, don't click that. 0.0 times 3.2 times 10 to the power of -4. Okay. All right, we're gonna get, let's do 2 sig figs. 5. So let's do 5.7. Actually, no, 5.6 because it's a 5 next. 5.6 times 10 to the power of -3. This is the concentration of the H plus ion, right? This is equal to, so different color, concentration of the H plus ion. Since we have that, once again, just like the previous question, we could do negative log of X, which is your concentration, to get the pH. And that's equal to negative log. Let's do 5.6 times 10 to the power of -3. All right, you're gonna get 2 point. Let's make it 2.3. 2.3, which is very acidic. Well, pretty acidic, yeah. Definitely acidic. Okay. Did I mess up anywhere? Let's see. So they got 2.84. 1.44. Did I square root it? Let's see. All right. Number's slightly off. I apologize. I'm just quickly calculate these. All right. So if you cross multiply this, you should get x squared is equal to 3.2 times 10 to the power of -5. And then let's square root this. Yeah, I got the same thing. Again, these questions are from ChatGPT. I couldn't find any weak acid and base problems from the internet, like worksheets. So I had to resort to these questions, but these are the similar type of questions you're going to see on an exam. Uh, as long as you understand how to do it, that's all that matters. All right. A 0.20 molarity solution of ammonia, NH3, has a Kb of 1.8. So now we have a constant base. This is the basicity constant. We're dealing with a base now. Set up ice tables and calculate the OH, pOH, and pH. Okay. So we're gonna have, let's write our equation. We have our base. Remember what a base is. A base is the one that gains a proton, which is a hydrogen. We're gonna assume, I'm gonna make it like a, we're gonna assume water, right? And you're gonna get NH4 plus OH. Essentially, this H2 is gonna give one hydrogen here. It's gonna reduce to one. Okay, beautiful. Let's start ice tables. I, C, E, initial change, equilibrium. We start with 0.20. H2 is a liquid, so we don't care about, again, I don't like these colors. H2 is a liquid, so we're not gonna care about it. We don't calculate it with it, so we're gonna put Na because we don't care about it. 0 and 0. It's important to find OH, the concentration of OH, right? So we're gonna minus some X, don't care about H2O, plus some X and plus some X, right? Again, same deal, X squared. Assume that X is negligible, 0.20 is equal to the constant 1.8 times 10 to the power -5 over 1. You're gonna get X squared is equal to 0.20 times 10 to the power -5. Okay. You could solve it like that. I'm just gonna go ahead and just take the square root right now, and I'm gonna put that in my calculator. So we're gonna do 0.20, 1.8 times 10 to the power of -5. Okay. Let's see what we get. So X, which is equal to the concentration of the OH, which is what we want, is equal to, we're gonna do it to let's make it two sig figs. Let's make it 1.90. Okay, that's X, right? That's our X. What is it asking for? Calculate the pOH and pH. So again, pOH is similar. It's the same thing actually. It's not even similar. Negative log of the OH concentration negative log of 1.90 times 10 to the power of negative 3, right? Let's see. All right, I got 2.72. So that's my pOH. And it's also asking for pH. So we're just going to do 14 minus 2.72. You're going to get 11.28. Again, I doubt ChatGPT is not a good source. Let's see if I got it right though. Yeah. So 11.28. That's what we got. Yep. So this checks out. And what was the pH? 2.72. Yep. Is our concentration correct? 1.90. Yep. Pretty good. All right. So this is how you solve pHs for weak acids and bases. And again, if you want to know how to do strong acids, they won't give you the constant unless they're trying to trick you. Yeah, they're not going to. Uh, and it's just straight up use the formula. And yeah, thank you. وعليكم السلام ورحمة الله وبركاته.